everyone. My name is Dr. Poonam Agrawal. I am Associate Professor at Department of Applied Sciences and Humanities at ABES Engineering College, Ghaziabad. The topic that we are going to discuss in this video lecture is chi-square test. We are going to discuss this topic into several parts. The first part being an introductory part. In this lecture, we are going to have the introduction of chi-square test. Next, we will understand the applications of this test, that is, the fields where this test can be applied. Next, we will take into consideration the conditions which should be kept into mind while applying chi-square test. After that, we will move towards the understanding of steps that will require to perform chi-square test, and then we will conclude this topic with the help of a few examples. So chi is a Greek word, and this is how it is represented. And since we are talking about chi-square test, we will write down this. We will give this the notation that you can see on screen. So chi-square test is basically a statistical technique. That this test was given by Carl Pearson in 1900 for the purpose of comparing the observed outcome of data with expected outcome. That is to identify whether the observed outcome and expected outcome are significantly different or whether the difference between them is quite insignificant. So this test proves to be an excellent choice to understand and interpret the relation between two categorical variables in a better way. Chi-square test finds its applications in a vast number of problems in statistics. However, there are two major applications of chi-square test, which we are going to discuss. And these applications are chi-square test as a test of goodness of fit and chi-square test as a test of independence of attributes. So before applying chi-square test, there are a certain conditions that we need to bear in mind. The first and foremost thing is the sample observations should be independent to each other and also should not be influenced by external factors. The total number of observations needs to be equal to the total number of experimental outcomes. Also, the total number of frequencies should be large enough so that the results that we get after applying chi-square test should be more and more reliable. However, it should also be kept in mind that the theoretical cell frequencies should not be very small for any category. Next, we come towards the most important part, that is the steps that are involved in applying chi-square test. So for applying chi-square test, first we need to declare null hypothesis. Null hypothesis is the statement that says that the theoretical distribution agrees to the experimental distribution of data. That is, the difference between theoretical distribution and experimental distribution of data is insignificant. It is denoted by H0. After declaring null hypothesis, we declare alternate hypothesis. It is denoted by H1 and it is contradiction of null hypothesis H0. It says that the difference between theoretical distribution and experimental distribution is significant in at least one category. That is, at least one of the proportions is different than specified in the null hypothesis. Next, we find degree of freedom. If the data has been distributed into n number of categories, then the degree of freedom for chi-square test is n-1. For example, if the data has been distributed into 5 categories, then the degree of freedom for this test will be 4. After declaration of null hypothesis, alternate hypothesis, and degree of freedom, we calculate chi-square statistics. We have a specific formula for chi-square statistics, for the calculation of chi-square statistics, that we will see after this slide. After finding chi-square statistics, we find out the value of chi-square tabulated from the table of chi-square test at a specific level of significance. Generally, the level of significance is taken as 5%. However, it may vary from case to case. If chi-square statistics is found to be less than the tabulated value of chi-square, then we say that the difference between actual and expected frequencies is insignificant. Otherwise, the difference is considered to be significant. All right, so now let us look at the formula of chi-square statistics. So chi-square statistics is calculated by the formula summation OI minus EI whole square upon EI, where OI is observed frequency of the data in each cell, EI is expected frequency of the data, which is also called theoretical frequency. So the results obtained by theory give us expected frequency or theoretical frequency, which is denoted by EI, and the results obtained after performing experiment or observation are called observed frequency, and they are denoted by OI. So this is how we find chi-square statistics. Next is chi-square tabulated. If you remember, I told you that you have to compare chi-square statistics with chi-square tabulated. If chi-square statistics is less than chi-square tabulated, then we say that null hypothesis is accepted. That is the difference between tabulated value and theoretical theoretical results and observed results is insignificant. However, if this equation fails, that is, if chi-square statistics is greater than chi or equal to chi-square tabulated, then H1 is accepted. That is, we assume that the difference between both of them is significant. Chi-square statistics, I told you that there is a formula, summation OI minus EI whole square upon EI. Chi-square tabulated, for finding chi-square tabulated, we use this table. In this table, the first column gives us degrees of freedom and the second column is about level of significance. I told you that generally we consider 5% level of significance, which in fraction becomes 0.05. So generally, this column is of most importance to us. We just find the degree of freedom that we require and we match this degree of freedom with level of significance. The intersection part gives us the value of chi-square tabulated. All right, so next we move towards a few examples to have a better understanding of chi-square test. So as the first example, we are going to discuss an experiment and the results or outcomes obtained in this experiment performed by Gregor Mendel, who was also known as father of genetics. He published the results of his experiment on peas in 1866. He collected a number of seeds and performed an experiment on those pea seeds, and he found that his experimental distribution of peas closely matched the theoretical distribution predicted by his theory of genetics. That is, he found that the ratio in which the pea seed should be distributed into various categories according to his theory of genetics was supported by his experimental distribution of data. So it was seen that if 556, where did I get this number from? 315 plus 101 plus 108 plus 32 equals to 556. So if 550, so it was 556 seeds were collected, pea seeds were collected, and it was observed that 315 seeds belonged to category 1, 101 seeds belonged to category 2, 108 seeds belonged to category 3, and 32 seeds belonged to category 4. His theory of genetics claimed that if you randomly select a number of pea seeds then their distribution into these four categories should be 9 is to 3 is to 3 is to 1. So this was the theoretical distribution of data, whereas this is the observed distribution of data. And the theoretical distribution of data says that if 9 plus 3 plus 3 plus 1 equals to 16, 16 seeds are randomly selected, then theory says that 9 seeds should belong to category 1, right? And so on. Now, if we want to verify whether the theoretical distribution of data matches with observational distribution of data, we need to apply chi-square test. And how do we apply chi-square test? For applying chi-square test, the formula that I told you is chi-square statistics equals to summation OI minus EI whole square upon EI. That means we will need only two quantities. First is EI, expected distribution of data, and OI, that is observational distribution of data. So let us see how we find out these calculations. First, we declare null hypothesis, which says that the difference between theory and the difference between theory and experiment is insignificant. Next, we declare alternate hypothesis, in which we assume that the difference between theory and experiment is significant. Now we have to see whether chi-square test claims that this statement is true or this statement is true. Okay. Next, we find degree of freedom, which is equal to n minus 1. Since the data has been divided into four categories, therefore degree of freedom for this experiment will be 3. Generally, level of significance is taken as 5%. So here also we consider it to be 0.05. Next, we need the value of chi-square statistics, for which we need OI, and EI. OI is already given to us as 315, 101, 108, and 32. We need to calculate EI now. So let us see how we find EI. So since there are four categories, we have to find E1, E2, E3, E4. E1 equals to 556 into 9 by 16. How did we get it? Out of 16 seats, 9 are expected to belong to category 1. And therefore, out of 556, 9 by 16 into 556, that is 312.75, are supposed to belong to category 2. Next, in E2, 556 into 3 by 16, that is 104.25 seats should belong. How many seats should belong to category 3? 556 into 3 by 16 again. Since the ratio for the third category was again 3, that is 104.25. And finally, for how many should belong to the last category? That is E4, 556 into 1 by 16, which is 34.75. Right? So this is the data that we have got. Next, we have to find chi-square calculated, or chi-square statistics, which will be equal to summation O1 minus E1 whole square upon E1, sorry, that is OI minus EI whole square upon EI. That is, the observed frequency for the first category was 315. So 315 minus expected value was 312.75 whole square upon EI, expected frequency 312.75. plus 108 minus 104.25 whole square upon 104.25 plus 101 minus 104.25 whole square upon 104.25 plus 32 minus 34.75 whole square upon 34.75. And when you solve this calculation, you get this value as equal to 0.470024. So we found that chi-square statistics is equal to 0.470024, whereas chi-square tabulated, that is chi-square at level of significance 0.05 and degree of freedom 3. Let us go back to the table. See, for degree of freedom 3 and for level of significance 0.05, this value comes out as 7.815. So this value came out as 7.815. The chi-square, this you can see very easily that chi-square statistics is less than chi-square tabulated, which means that H not accepted. That means the difference between theoretical results and the experimental results are insignificant, or theory is supported by the experiment. So this is how we have performed chi-square test on this P experiment. Let us take another example which says that the following table gives the number of accidents that took place in an industry during various days of the week. Test if the accidents are uniformly distributed over the week. All right. So there is a factory, there is an industry, and the number of accidents that took place in this industry. The number of accidents that took place in an industry are given by this table. On Monday, 14 accidents occurred. On Tuesday, 18 accidents occurred, and so on. Now, we want to know whether the accidents are uniformly distributed over the week, that is, every day has equal chance for the accidents, or whether there are a few days, some days where which are more prone to the accidents, there, that is, where there are more chances or less chances for the accidents to happen. Okay, so we will verify this thing with the help of chi-square test again. So as I told you that the first thing that you need to declare is null hypothesis, which always in which theory is always supported by the experiment. That is, if the claim is that the data is uniformly distributed, we want it to be true in H naught null hypothesis. So in H naught, we declare that the accidents are uniformly distributed. Accidents are uniformly distributed over the week. Over the week. In H1, we assume we take the contradiction of H naught, that is, the accidents are not uniformly distributed. Okay. Next, we take degree of freedom. Since the data was given for 6 categories, therefore, degree of freedom will be n minus 1, that is 6 minus 1, that is 5. The level of significance is generally taken as 0.05, and again we are taking it as 0.05. Now, we have to see whether the data is uniformly distributed over the week or not. So, according to observation, the data distribution is given to us, and 14 plus 18 plus 12 plus 11 plus 15 plus 14, that is 14 plus 18 plus 12 plus 11 plus 15 plus 14 is equal to 84. So if 84 accidents have taken place, then according to theory, 84 by 6, that is 14 accidents, should take place each day. Hence, the observational data is 14 into 6 categories: 14, 18, 12, 11, 15, 14. Whereas theoretical distribution of data is 14 each. And therefore, chi-square statistics, which is equal to summation OI minus EI whole square upon EI, will be equal to will be equal to 14 minus 14 whole square upon 14 plus 18 minus 14 whole square upon 14 plus 12 minus 14 whole square upon 14 plus 11 minus 14 whole square upon 14 plus 15 minus 14 whole square upon 14 plus 14 minus 14 whole square upon 14. When you solve this value, you get it equal to 2.1428. So chi-square statistics came out as 2.1428, whereas chi-square tabulated, the tabular value of chi-square at level of significance 0.05 and degree of freedom 5 can be seen as 11.07. Since chi-square statistics is less than chi-square tabulated, we claim that H naught accepted. That is, the theory is supported by the experiment, or we can say that number of accidents are uniformly distributed over the week. Number of accidents are uniformly distributed over the week. All right. So these were a few examples related to basics of chi-square test, which told us about the working process of chi-square test. Using this, we can verify whether the theory is supported by the experiment or not. So in the upcoming lectures, we will understand goodness of fit and test of independence. So here are the references. Thank you, everyone.